All right, we're gonna get started. I'm gonna turn on the screen for you guys to see. Sorry about for that. All right, so I put together a chapter 5 review for you guys. Questions like this will be on the test. So there's a free response. I put the free response first. And then I put your multiple choice practice, and then I put a Frappy practice. And the Frappy is so super easy. All right, so the probability of drawing a jack, queen, or king from a standard deck of playing cards is approximately 0.23. Explain what this probability means in the context of drawing from a standard deck of playing cards. So it's just asking you basically to interpret the probability. So if you draw a card, and replace it many times, why do I have to say that?
Law of large numbers and stuff.
Yes, law of large numbers. You need to make sure that it happens multiple times, okay? So remember when we did the penny flips, like at first it was 50%, but then it like jumped to like 1/3 or it was 2/3. And then over many times is when it averaged out to that 50. So if you draw a card and replace it many times, 23% of the time, you would draw a jack, queen, or king. So he brought up a good point. Remember the law of large numbers. So you might want to look that up tonight as well. All right. So does this mean if we repeatedly draw a card, replace it, shuffle, and draw again 100 times, we will draw a jack, queen, or king 23 times? Why or why not?
No, because that number's not that large.
No, not quite. You're right with the no part. So why or why not? Right. So each time you draw, it's going to be different. So what we'd expect we would expect 23 out of 100. But we aren't guaranteed. So remember, it's an average. It's an estimate. It's not an exact. All right. So number 2 is designing and carrying out a simulation, and you should know how to do this. A popular airline notes that in general, 95% of individuals who purchase a ticket for a 10-seat commuter flight actually show up for the flight. In an effort to ensure a full flight, the airline sells 12 tickets for each flight. So when you hear about planes being overbooked, they really do this. They sell more seats than what they have, so to ensure that they're full the entire time. So instead of selling 10 tickets, which is how many seats are on the plane, they sell 12. Okay. So in an effort to ensure it's full, they sell 12. Design and carry out a simulation to estimate the probability that the flight will be overbooked. That is, more passengers show up than there are seats on the flight. All right, so how would we do this? If we're doing a simulation, remember that's we're choosing 12 out of this. How many people? How many people can we use for this? 95% of individuals who purchase a ticket for a 10-seat commuter flight. So 95%, what number of people can we use to make it easy? 100. So 1 through 95. We're going to label those to represent those that show up, and I'm just kind of minimizing what I write. What am I going to do for the ones that aren't going to show up? 96 to 100. And sorry, we're going to make it 0, 0. The reason I'm going to make it 0, 0 is because I'm going to use the table of random digits. If you did random integers, you could use 100. Is everybody good? So it depends on what you have. So I want to do this one so that I get the table D in there. If you were doing your calculator, then you could just go ahead and put the number 100, okay? for no shows. So if we use a random line, well, somebody should be on time. From table D, what are we going to look for? Look for 2-digit numbers. Within range. One more thing about that. Non-repeating. How many are we going to choose?
95.
Oh. How many?
12.
12. Why are we choosing 12?
The airline sells 12 tickets.
12 tickets. So we're trying to figure out who got the tickets. Stop after 12 tickets. And count the number of seats. Can we just do this once? How many times do we have to do it? Many times. Yeah, don't be crazy. Just many times is fine. Repeat many times. And record if overbooked. That's all you have to do. When are they overbooked? If they all show up. If 12 are in the shows. So if you get not just 12, but how many? 11 or 12 in the 0-1 to 95 category. Okay, just throwing that out there. So this is it. This is designing that simulation. You can't carry it out because we don't have all the stuff for it, but we're going to move on. All right. Sorry. Consider drawing a card from a shuffled fair deck of 52 playing cards. How many possible outcomes are in the sample space for this chance process? So how many outcomes are there in the deck of cards?
52.
Perfect. What's the probability of each outcome? Perfect. That's it. Is everybody okay? All right, so far I think 2 is probably the hardest one to do, just so much to remember within that problem. These are fairly easy. Define the following events. A, the card drawn is an ace. How many aces are in a deck? 4. Y'all might need a deck of cards tomorrow, I'm just saying. The card is a heart. How many hearts are there? 13, okay. So find the probability of A and the probability of B. How many aces did you say there were? Out of 52. Probability of B, that's as good as it, y'all don't have to do the percentages for me. Okay, 4 out of 52 is perfect. What's your probability of B? 13 out of 52. You can reduce that if you want to, but there's no point. This is fine. So what
Is it wrong to simplify probabilities like 1
Absolutely
out of
not.
13?
Absolutely not. You can do whatever you want to. They're
Just
all the
unnecessary.
same. Yep. They don't count off if you don't simplify. So why do the work and make a little mistake? So what happens if you round wrong or you simplify wrong just on accident? Just leave it, is how I feel about it. All right, what does this mean? All of the cards that aren't aces, so not aces. How can I figure that out? 1 minus your aces, so the complement rule. And that would give you what? Make it easy on yourself. 1 is 52 out of 52, minus 4 out of 52, 48 out of 52. I know that's tough math. I know. It's okay. Are events A and B mutually exclusive? Why or why not? Why no? They can happen at the same time. So you can have an ace of hearts. So know the difference between mutually exclusive and independent. Independent, you have to have a formula to test for. Mutually exclusive is, can they happen at the same time? Got it? All right, use a two-way table to display the sample space. So we have A and B are an ace and a heart. So we're gonna have A and not A. So a heart and a not heart. I'm sorry, ace. Ace or not ace. And then B is gonna be heart or not heart. In your deck of cards, how many ace of hearts are there? 1. So that means how many other aces are there? Aces. 3. So this is an ace, but not a heart. It's going to be 3 of them. All right. What about not ace, but hearts? 12. And then what about not ace and not hearts? Think about it this way. How many total cards are there? 52. How many are hearts? 13. So we take that away. It's 52 minus 13. Minus aces that are not hearts. 36. So anything that is not an ace, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, jack, queen, king, but then take out the hearts as well. Okay.
Do we need to put total?
You don't have to total any tables at all, only if it makes you feel better. When you're working out your probabilities, it might be nice to have them, but for this one, you don't have to put the total on there. Use a Venn diagram to display the sample space. So we're going to make our Venn diagram. We have event A and event B. I told you the best place to start is where? In the middle. Where's the overlap? How much overlaps? 1. All right, so this is where your table may come in handy a little bit. So we're talking about all of A. So if you look right here, all of A is how many? 4, but we already used 1. So how much is just A? 3. Same thing with B. B is this row across. How much goes in just the B circle? How much goes in not A and not B? There you go. Any questions? What does the next one say? A or B. What does that mean we have to do? Good. If there's overlapped, we definitely want to subtract it. And we already know that they are because they're not mutually exclusive. Know this formula. We already did these probabilities. They're at the top. Okay, we already did them. So what's the probability of A? Probability of B? 13 out of 52. A and B? 1 out of 52. Which gives you a total of? You can reduce it or not. It's up to you. Again, I would not, just in case I made a stupid mistake. Is that good? Is there a relationship between gender and candy preference? Suppose 200 high school students were asked to complete a survey about their favorite candies. The table below shows the gender of each student and their favorite candy. They are totaled up for you. Define A to be that a randomly selected student is male. So I'm going to go ahead and put an A above this as well. And that a student is liking Skittles would be our B. Are the events A and B independent? So what's the formula for independence? Yes, they have to be the same, but the percentages of what? Or the proportion of what? What's your formula? Y'all don't know your formula?
Isn't it P A given B equals P of A?
If you do A given B, it has to be the same as A. Or whichever one you choose is fine. If you screw it up, you can't really. Always choose the first one. Always choose the first one. Or you could do the probability of B. Either one of these will get you the credit, okay? Either one of these will get you the credit. Does not matter which one you choose. I did this one. Again, you can do the other one. It doesn't matter, but I'm going to do this one. So what is the probability of A? Probability of A is that they're male. So how many males are there? Say it again. 120 out of 200. This gives you 0.6. All right, probability of A given B. Remember, the probability of A given B is the probability of, what's your formula for that? Over B. Perfect. So A and B is how much? So male and Skittles. You can look in your table, male and Skittles. How many just like Skittles? Doesn't matter. 140. Look, I found another typo. There's like 4,000 typos in here because I was doing it really, really quick yesterday. 80 over 140 is 0.5714. Are they independent? No. How do you justify your answer? You just did. But another way to do it is saying P of A does not equal P of A given B. Guys, you need to know that formula. And again, the other formula will work the same, okay? What would be your probability of B? B is Skittles. 140 out of 200. What's your probability of B given A? So A and B was 80. And then over A would be, what's your total males? 120. Those two would not be the same. Okay. So it doesn't matter which one you choose. All right. A study of high school juniors in 3 districts, Lakeville, Sheboygan, and Omaha, was conducted to determine enrollment trends in the AP mathematics courses, calculus, or stats. 42% of students in the study came from Lakeville, 37% from Sheboygan, and the rest came from Omaha. In Lakeville, 64% of juniors took statistics and the rest took calculus. 58% of juniors in Sheboygan and 49% of juniors in Omaha took statistics while the rest took calculus in each district. No juniors took both. Describe this situation using a tree diagram and find the probability that a randomly selected student from the study took statistics. So what's the first percentages they give us? So where they're from, right? How many different places are they from? 3. They're from Lakeville, Sheboygan, and Omaha. How many came from Lakeville? 42. How many came from Sheboygan? How many are the rest? Is everybody good? You had to figure that one out yourself. Those juniors either took calculus or statistics. It says in Lakeville, 64% of the juniors took stats. So stats in Lakeville is 64. So what would calculus be? 36. Sheboygan, how many took stats? 58. So how many took calc? 42. And then in Omaha, how many took stats? So how many took calc? 51. So that's your tree diagram. Read the whole problem. What's the probability that a randomly selected student from the study took statistics? How many different ways can they take statistics? How many different ways? 3. We should add 3 probabilities up. So the first probability is going to be Lakeville in statistics. So Lakeville is 0.42, statistics is 0.64. So this is what we're looking at. From Lakeville, took statistics. From Sheboygan, took statistics. So we're going to add that. 0.37, 0.58. And then Omaha took statistics, 0.21 and 0.49. This will give you a total of 0.5863. Everybody okay? Know how to use that tree diagram. Make it and use it. What?
Never.
Okay. Everybody good? All right. Consider the last situation. Find the probability that a student is from Lakeville, given that they took statistics. So the probability of Lakeville given statistics. What's the formula for that? Probability of, what's your given formula? All right, Lakeville and statistics was the top of that tree. Lakeville was 42%, statistics was 64. Maybe the vice versa, I don't know if I wrote them the right way. And then what was our probability of statistics that we just found? 0.5863. Put that straight into your calculator, 0.4585. That's it. So basically, guys, know this given formula. Okay, you have to know, given an independent formula. All right, so that's all the free response practice. Not too bad, right? It's not terrible. That number 2 again was the worst one, but it's just because it's a lot of writing. All right, so then the multiple choice tries to trick you. We're gonna do this like slow, okay? So you need to understand what you can mark out and what you can't, vice versa. I think that's the problem when you take your multiple choice. I know some of you are probably looking them up or whatever. I don't care. When we get to the AP Stats exam, you're gonna be in trouble if you keep helping each other, okay? That's the problem that I have with you helping each other. Not that you're helping each other. If you're giving the answers, that's one thing. If you're helping each other, that's completely different, okay? Does that make sense? Start helping each other instead of giving each other. All right. The probability that you will win a prize in a carnival game is about 1/7. During the last 9 attempts, you have failed to win. You decide to give it one last shot, assuming that the outcomes are independent. What does that mean? That they're independent.
Doesn't matter if you lose the game before you.
Doesn't matter. It's just like a coin flip. It's independent. It doesn't remember what happened and it goes right back to normal. Okay. So every time you flip a coin, you have a 50-50 shot of getting it. So every time you play this game, what's the chance you're going to win? And that would be? That's it. So you got to be smart about that. So independent means one does not depend on the other. So it does not matter. If you need to make little notes on your paper, it would be nice to have this out while you're taking your test. Okay. Anything that you feel like is important that I say, you may want to write down. A friend has placed a large number of plastic discs in a hat and invited you to select one at random. He informs you that half are red and half are blue. If you draw a disc, record the color, replace it, and repeat 100 times. Which of the following is true? It is unlikely you will choose red more than 50 times. If you draw 10 blue discs in a row, it is more likely you will draw a red on the next try. The overall proportion of red discs drawn should be close to 50. The chance that the 100th draw will be red depends on the results of the first 99 draws, and all of the above are true. So I know what the answer is. I don't need you to yell out the answer. Let's talk about the ones that are not the answer and why they are not the answer. Okay, let's talk about why. Not like, okay, well, it's just not this one. What? Pick one that you absolutely know it is not and talk to me about it.
B,
Why is it not B?
because the events are independent.
Yes, so this one, because we replace them, we have the same chance of drawing it out. We talked about this with the babies, the person getting that like boy every time, boy, 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 boy. Just because you get 4 boys does not mean you're going to get a girl the next time. All right. Yeah, so that crosses E out because we know that that's not right. Why D? Same exact reason. Doesn't matter what the first 99 are, you still have the same result or the same probability on the last one. All right, so now we've narrowed it to A and C. Yeah, can I draw more than 50 times? Yeah, if I take many samples, I could draw 49 one time, I could draw 51 the next time and still average out to 50, right? So this one would be marked out just because we could have over or we could have under. It's what it is in the long run. So your best answer is C. All right. Guys, just because it's multiple choice does not mean you don't have to do work. Okay? That's another thing. You might have to do a little bit of work to get your answer. All right. 2A table below gives information on males and females at high school and the preferred music format. You select, should stay one student from this group at random. Which of the following statement is true about the events prefers vinyl and male? First of all, look at all your answers and tell me which ones I can eliminate and why. Say it again. Why can I eliminate E? Are you let me hold on that one for a minute. We can eliminate A? I would not eliminate A to begin with. Okay. Whoa. You're confusing your definitions, I think. Okay. What is mutually exclusive and what is independent? Remember, for independent, what did I tell you have to do? You have to do a formula. Have we done any work yet? So we cannot rule out whether it is or is not independent. But what can we rule out?
Any that say that they're not mutually exclusive.
Why?
Because they can happen at the same time.
Yes, because you can have male and vinyl at the same time, right? So it's the ones that say not mutually exclusive that we can mark out. And then that causes you to be able to mark out E because we can tell whether they are mutually exclusive or not. So that's why I said hold off on that one. So now we've limited it to A and C. So we have to figure out if they're independent, and how do we do that? With the formula. So what I did was the probability of male. Is that equal to the probability of male given vinyl? You could do it the other way. What's the other formula you could use? Instead of using male, we could use vinyl, but vinyl has to go in the front of the other side. I don't care which one you use. This is the one that I used, but either or will work. What's the probability of male? When we run out of time, we'll come back in, guys. 300 total males out of 550. Somebody do that work for me. 300 out of 550. Yeah, give me a decimal. 0.54. Good enough. 0.54. If it's 5.5, it's fine. You'll see. All right. Probability of male given vinyl. So male and vinyl was what? Say it again. 48. Out of total vinyl, 88. What's 48 out of 88? The same exact. So they are independent. So which one is your answer? Good. Not A. What did I do? I crossed out the wrong ones. Keep B. Yes, I did. Keep B and D. Okay, sorry, it should be B. They are not mutually exclusive, but they are independent. Yeah, I'm sorry. No, ask, always ask. It should be B. I'm sorry. No, yeah. When you realize it, ask me. I'm so sorry. I know, y'all,
I'm like, okay, I'm okay with it.
and I literally said cross out the ones that are mutual. Yeah, it's okay though.
What is it? B? Or D?
B, it's B, it's B. They are not mutually exclusive because they happen at the same
For
time.
the first time, I think Rachel said something about the not usually exclusive or something, and that's why you were like listening.
Yeah, I was listening right. See, so sometimes I can't. It's not all the time. Quit looking at me like that. I hate you. Ugh. All right, sorry, y'all. Next time, yell at me sooner. Okay, this should be 7.2%, just so y'all know. Again, I was doing this really quick. People with type O negative blood are universal donors. That is, any patient can receive a transfusion of O negative blood. Only 7.2% of the American population is O neg blood. If 10 people appear at random to give blood, what is the probability that at least one of them is a universal donor? So this is your key right here, is at least one. And I told you this is that weird formula. So we're going to find first the probability that they're not O negative. So we're going to do the complement first. So we're going to do 1 minus 0.072, which is 0.928. How many people are we testing? 10. That gives us 0.4736. This is the probability that 10 are not O neg. But we need the probability that they are, that one of them is. So then you have to subtract that from 1. So this is the probability of O neg, which is 0.526. So anytime you see at least one, find the complement, put that to the power, and then do the complement again. Die is loaded so that it should say number. Sorry, I told you there's a lot in there. Comes up 3 times as often as any other number. What is the probability of rolling a 4, 5, or 6? So listen carefully. This is how you do this. 3 times as much, 4 times as much, 5 as much. So you have a chance on a dice of getting 1, 2, 3, 4, 5, 6, right? On a normal dice. But then they load it, so 6 comes up 3 times. So we got to put 3 6s on here. How many total outcomes is that? How many total outcomes is that? 8. How many of them are 4, 5, or 6? That's all you do. Is everybody good? All right, so we barely did any of these, but these are kind of more common sense-ish. So it says you draw 2 candies at random from a bag that has 20 red, 10 green, 15 orange, and 5 blue candies without replacement. So you're taking one out, and then you're drawing another one without putting the other one back in. What's the probability that both candies are red? So what do we have the first draw? How many red candies do we have? 20 out of? We don't put that one back in. We don't put that one back in. So then what do we have? And we're multiplying those probabilities together. That'll give you 0.1551. All right. An event A will occur with probability 0.5. It should say an event B will occur with a probability of 0.6. The probability that both A and B will occur is 0.1. So which one can I go ahead and mark out?
A and B are complementary.
Which one can I mark out?
A and B are independent.
That they're mutually exclusive.
Mutually exclusive. Why mutually exclusive? Automatically.
Says they can both occur.
They happen. All right. What does it mean to be complementary?
They make one together, but they don't. No.
It means that they would be kind of opposite of each other. So if A was 0.3, what would B be? Like 0.7. Is that the case on this one?
That's what I meant, like they add up to 1.
I got what you said. I got it. Perfect. All right. So how do we tell if they're independent? Okay. So I did probability of A given B. We said that the probability of A was 0.5. There's not really a lot of work to this, okay? A given B is the probability of A and B, which is 0.1, over the probability of B, which is 0.6. And that reduces to 0.166. So are they independent? No. So now the question is, does A and B always occur? Here's your probability. A or B. How do I do A or B? Add them up and subtract the overlap. Probability of A is 0.5. Probability of B is 0.6. The overlap is 0.1. What does that leave me with?
One.
This is 1.1 minus 0.1 is 1, which means 100% of the time. So does it occur always?
Yeah.
Yes. So then you can eliminate E. I'm going to go out and come back in, guys.